You're doing well. So this is day 3 of my DSA series at Entrance and Beyond. And today we will be looking at question number 121, best time to buy and sell stock. So this is a classic question and I think you should definitely try it out on your own before actually looking into my solution. And hopefully you'll get an understanding about how we're going to solve this question. So let's dive right in. So the question states, you are given an array prices where prices of I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So let's look at the test cases. So the first test case is prices is equal to 7, 1, 5, 3, 6, 4, and the required output is 5, and they have even provided an explanation where they say buy on day 2, so day 2 basically means price is 1, and sell on day 5, that means sell when price is 6, and the profit that we get is 5. So note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. So that is something related. That's really logical, right? You can only sell a stock once you have bought it. So you have to search for the maximum profit that you can get. And for that, it's clear we have to always look ahead of the given element. And that will probably make more sense when I actually draw it out and explain the solution. And let's look at the other example. We basically have prices. It's equal to 7, 6, 4, 3, 1. And over here, the output is simply 0. And why is it 0? It's 0 because we can't really gain any profit because as you can see, prices is sorted in descending order. So there is no way in which we could sell at a price higher than the price at which we bought something. So over here you can see that the output is 0 and we are provided some constraints, and that is all that is given in this question. So let's now try to map it out. So the brute force approach that we could follow to solve this question, it's really simple. What we're going to end up doing is we're going to start off at an element. So suppose this is what we have right now, correct? This is the array that we have. So essentially what we're going to do is we're going to start off at a given element, and we're going to find out the maximum profit that we could get if we buy that, if we sell that given stock. So for example, we're going to start off at 7. What we're going to do is we're going to start off as the first element 7. And then we're going to search ahead in the array and find out the maximum profit that we could get if we have purchased the stock. So over here, the profit basically becomes minus 6. Over here, it basically becomes minus negative 2. Over here, it becomes negative 4. Over here, it becomes negative 1. And over here, it basically becomes negative 3. So as you can see, the maximum profit thus far would basically be negative 1. Now we're going to do the same for 1. We're going to look at all the elements that are present after 1, and we're going to find out the maximum profit. So as you can see, the maximum profit over here would be 5, and 5 is basically greater than the maximum profit that we had thus far. That was minus 3. So we're going to store 5, and this process is going to continue. The only problem with this approach is it ends up taking big O of n squared time because we essentially are going to use 2 for loops. One to find out the starting element and one to find out the index where we want to sell a given stock. So this is a brute force approach. You can go forward and try to implement it yourself. It's quite straightforward, and you can add that in the comment section if you want to. Now let's look at the better or more optimal approach. So we're going to again copy this test case, and then we're going to see how we can end up solving this question. So this is the test case that we're going to look at. This is the array that we have, and we're going to move forward with it. So this is the array that we have in hand, 7, 1, 5, 3, 6, 4. Now, in order to maximize your profit, something that probably struck a chord was that we must buy at the minimum price. So listen to this clearly. We must buy at the minimum price. So I'm trying to say we must buy at minimum price and sell at maximum price. So I'm trying to say this relatively. So when do you get the maximum profit? So it's quite clear. You could buy it at the cheapest rate possible, and you can sell it at the maximum rate. So then you can say that the profit that we get, they would definitely get maximized. So what we're going to do is we're going to track out the minimum element thus far in the array, And we're going to compare this element with the minimum element. And we're going to see what the result gives us. And we're just going to get the maximum result from this, and that is what we are going to end up returning. So let's traverse through this array so that it makes sense. So initially we're going to assume that the first element is the maximum element, and since there always is going to be one element, so let's assume that 7 is the minimum price that we saw thus far. So what would the profit be? The profit would basically be the current price minus minimum price. It's 0 right now. Then we're going to go at 1. So as we can see, 1 is less than 7. So our new minimum price would become 1. And we are going to compare 1 with minimum price. So current price minus minimum price, again, it would yield 0. Then we're going to go to 5. Now 5 is not less than minimum price. So minimum price remains 1. And then we're going to find out the profit, assuming that minimum price is 1. So profit becomes 4 over here. We go to the next element, 3. Again, 3 is not less than minimum price. So profit over here would become 2. And what we're doing is we're using an element to store the maximum profit. So maximum profit, initially it was 0. And then once we get a 4, we're going to replace it. 2 is not greater than 4. No need to replace. Now we're going to go at 6. Now 6 is greater than minimum price. So we're not going to change minimum price. So profit that we get right now is 5. It's greater than this. We're going to end up replacing this, and in the end we basically get 4, and the profit becomes 3. No need to replace, and 5 is our answer. So this is all that we're doing. Essentially we are storing the minimum price seen thus far. And why we're doing that? Because we are anyways going to buy before we sell, right? So we only care about the minimum price that has been seen so far, because we can only sell something that we have bought. So that is why we only care about the prices that have appeared in the past, and we are going to use that as a reference to calculate the profit that we end up getting. So that's pretty much what happens in the background. So now let's try to code it up. Hopefully you understood the logic behind this, and if you didn't, you can feel free to drop down a comment, and I'll try to explain it in better terms. So now let's try to code it up and actually get a clearer understanding of what we're going to do. So I'm going to take a variable. I'm going to take int min profit. So this is basically a minimum buying price that we have found till now, and we're going to equate it to prices of 0, because anyways there is always going to be one element. And then we're going to have int max. It's going to be sent up at a minimum. Initially we don't really care. Now what we're going to do is int I is equal to 0. I is less than prices dot size. We're going to end up incrementing I. Now first we're going to check if prices of I, if it's less than minimum price. Okay, not minimum profit, it should be minimum price. That makes a bit more sense. Well, okay, so if prices of I is less than minimum price, we're going to reset minimum price. So we can say that minimum price now is equal to nums of I. That is what we're going to do. And now we're going to calculate. So we're going to do maximum, or we can, okay, yeah. So we already have a variable for that. So maximum is equal to, okay, so we can say max is equal to max of, okay, this is max profit. So we can say max profit is equal to max of max profit and nums of I minus minimum price. And now what we can do is we can just end up returning max profit, and this should yield us the required result. So after running it, okay, a slight problem came place. And what is the problem? It basically says nums is not there. So yeah, we made a pretty silly mistake. So sorry for that. We're going to do prices of I, and over here again we're going to do prices of I, and I think everything else looks like it will work perfectly fine. So you do have to make sure about the name of the vector that is being passed. You don't really want to max it, and again we messed up with the variable name. So these are some of the things that you have to take care of. Like you can't mess around with the variable names and do cross check. So we get the answer, and it runs in big O of n time. Hopefully you understood something from this video, so thank you so much for tuning in.